All right, I'll do a sound check. Hello, everyone, and welcome to today's webinar. Our focus is the DM32 Smart Gauge. Kind of do an overview and explain to people why this is such a great device. It's actually changing how a lot of people do testing, but we want to make sure that you're using it, if you are using it, the best to your ability. So that's our goal, is to kind of answer your questions and make sure there's some features in here that you're aware of. That's who you got with us today. So that is Jay West on the left. He's a new picture, which I haven't seen yet, so we'll update that next time we go this round. And this is me on the right. So we welcome you. So we're both independent trainers for Retrotec, and we help them with their webinars, training, a variety of other stuff. So if you have any questions, you want to make sure things we cover, please throw those out. And here's our clue to remind ourselves to record. So I am recording. I'm sure Jay's doing it in the background. And this kicks in the meat and potatoes. So there are a few things we'd like to cover in ahead of time, and that helps make sure everybody's on the same page. We get some information about what we're headed towards. So today we're going to cover some of the ports and connections. I will focus on the firmware, which is something that I know that most people aren't really paying attention to. The interface, calculating results, some common errors, and running other manufacturer fans, which means Energy Conservatory, and how to do the whole flow. So those are some of the things we're going to touch base on today. I made this slide a couple of years ago, actually, but I thought it was kind of pertinent to show the history of when some of these things came out. So that's actually one of the early duct testers, and these are some actually early gauges, and these are monster-sized devices. They're probably close to 2 feet by almost 3 feet, maybe 2.5 feet, weighed a good anywhere from 20 to 40 pounds. And then you see them start getting smaller, and you can see the goal of Retrotec and Colin Genjin that is trying to put something that is the gauge and a keyboard together. So you have a screen, you have the ability to enter information, and then he kind of got up to date with where a lot of devices were going, and they were way ahead of the curve with touchscreen and built-in Wi-Fi and a lot of great built-in calculations. Most of what we're going to talk about today is what the gauge does by itself. So you may or may not have one that's Wi-Fi, and everything we'll talk about today will do that. So if you have one that's non-Wi-Fi, these are all the amazing things that it does today. So let's keep moving. So one of the things I do try and make sure people understand if they're new to testing about the gauge and the smart gauge. So so there's a basic layout. There's a channel A and a channel B. And this is actually a 2-channel gauge. So there's actually 2 gauges in one. So if you really look at that in general, and if you split channel A and channel B, you can see that you actually have 2 gauges in one. So the red and blue ports are for channel A. The yellow and green ports are channel B. Channel A always is giving you your results. All right, and we'll kind of scroll through here. So my test pressure is always my test pressure is always channel A. Channel B always gives me my results. So I probably messed that up. I'll repeat it again. So channel A is always giving me my test pressure. It only really gives you in the pressure that you're actually testing with or trying to establish a test pressure. Channel B is always what your results are. So it could be in a pressure, it could be CFM, it could be actually calculating ACH50 or CFM per 100 square feet, or a variety of other metrics that may be European or other standards. It does have digital sensors with a 5-year calibration. This is kind of a new thing for the industry, and it does allow you to make sure you're not worried about your gauge having to be calibrated every 1 year, 2 years, and we'll talk about field calibration versus manufacturer calibration in a second. It does have some great tapered connections. These actually, when you see these in the real world and you start to use them, you realize why they're so valuable. And that is that they actually connect the tube on all sides, from the inside of the tube and the outside of the tube. And it doesn't actually mess up the tubes themselves. It doesn't cause little burrs or make them loose. And they actually stay very well connected when they're on their ports. So there are, if I'm going to do a duct test, these are some of the connections I thought I would toggle through real quick. So my input is going over the ducts so that I can establish that my test pressure, which is comparing the room or really outside from the reference in the red to the ducts, so I get my test pressure of 25 pascals. And the other side is always going to go to the fan itself. Some of the fans actually have 2 connections, but in general they always have 1 yellow connection. So yellow to the yellow fan, and blue just goes to the, well, I guess maybe they made blue duct mask to help you with that connection, but I don't think that was the intention. The opposite is with the blower door. So I'm going to run my reference to outside, so I'm comparing outside as my reference to input on the inside to get my pressure difference. And again, for most of the blower door fans, we're only connected to 1 yellow tube. I will talk about some of the wired connections. This is actually a common question that comes up when we run these webinars, and that is that the Ethernet is pretty much considered to be almost unlimited, with unlimited number of gauges for the most part for in terms of reality. And you can go about 100 meters, 325 feet with 1 wire, or if you're going to use a powered hub or extenders, you can actually go as far as you need to. And then at the end, you're usually going to end up with some kind of a hub and a router that kind of puts everything back into the computer, because when you have multiple gauges, that's what you're going to be using. USB is limited by 15 feet in general. Most of your USB cable, your cords you're used to are probably 3 feet, 6 feet. And you can get some that actually have boosters or repeaters inside, and you can actually go up to 5 times those kind of lengths. There is some maintenance and updates that I added to this slide or to this PowerPoint to make sure we're at. So we know that my calibration is every 5 years. What's really important about that is to register your equipment. Again, so if you bought it from somebody else, we want to make sure that you register your warranty and also register for calibration updates. All those kind of things allow you to stay in touch with what Retrotec is doing, or if there's any kind of issues, you're in the know. We will talk about how to confirm your gauges in calibration, to do a field check, and we'll definitely be touching on update firmware. So the one is you're going to keep track of your 5-year span here, and the others you're actually going to be kind of doing more regularly. So if you don't check your gauge at least once a month, you may find out that you have some concern or issue with your gauge that you should have paid attention with. And the firmware is updated not every month, every other month. There's new features, or somebody may have found a glitch that they're able to fix. So these are things we want to make sure that you are able to keep up with. Here's some information on the field check. These are in the actual quick guides, whether it's a blower door or the duct tester, the manuals. All these things have this information about how to do that. And this has actually been recently updated. We did a webinar with ResNet, and this is a common issue or a common concern with ResNet, that is your equipment been checked recently, and did you document it? So one of the first things you're going to be doing is actually making sure your gauge is set for pressure, so that channel A and channel B both have pressure. We'll kind of go through how to change some of those results in a minute. And Retrotec now has a field check, which I know Jay's in the background frantically finding the link, and he'll send that out to you. So what this does is actually, it's a Excel spreadsheet that allows you to pick the kind of device that you have, and you can enter your information, and you go through the instructions and tells you how to connect the gauge and what to do, and you end up with something you can save that it actually confirms that it does pass your field check. So it is something that you can send to your provider or QA provider, or just document that your equipment was regularly checked. So what we changed in the procedure that you may have been used to before is that the blower door and the duct tester umbilicals, all of the tubing that comes with the system, both have a yellow tube that's about the same exact fixed length. So the goal was to try and use something that was a common comparison, whether you have blower door or duct tester. You can just use the yellow tube and actually check your results. So basically what you're going to do is you're going to check the input on both channel A and channel B. You'll check the reference on channel A and channel B. And notice that the numbers are usually around this 200, maybe 270, 260, somewhere in that range. And that pressure is created when the yellow tube is actually put on those ports, and actually creates a small pressure. You're going to enter those numbers in that sheet that I had a second ago, and it tells you if you're passing. Basically what you're after is, are these within, in theory, 1% of each other, and the sheet actually calculates it for you automatically. If you're close, but not at the 1%, not the end of the world. It also confirms that you're checking your tubing. So you do want to check your whole tubing section, whether it's the blue or the green or the red or any other tubing you're using, but your numbers may be slightly different. The longer the tube, the smaller the pressure, the smaller the number. If you're just going to use a little short piece of tubing, you could end up with numbers that are 7, 8, 900 Pascal, but our goal was to find something that would be a good standard. Some of the things you want to do is while you're checking all your tubing is to make sure you don't have any moisture or water in your tubing. These cause massive errors. So again, we really are focused on the gauge. We're also focused on the maintenance of what you're doing with your gauge and how to make sure you don't have or avoid errors. So a lot of people may be testing with moisture from either snow or rain or something outside, or didn't realize it, or they left their tubing in a place where it actually was able to get moisture inside. So you basically just shake it out, or you can test it with your gauge to confirm if you have any kind of blockage. What it will show you is one port trying to read pressure and the other one almost being zero. Sometimes you may have a slit or a cut, so if your numbers disappear rapidly, like they may have some pressure, then they disappear, it usually means you probably have a slit or a cut in your tubing. Firmware, we cannot stress enough the amount of people we talk to out there in the real world. They're like, I don't know, I haven't checked it in a while. So the firmware is something you really want to make sure you're up to date. In fact, if you call tech support, the first thing they'll ask you is, what's your firmware version and are you up to date? So when you first turn on your gauge, you can see it on the splash screen. It's at the very top. And after the splash screen disappears after about 2 seconds, you can also see it on the very bottom screen there on the left. It'll tell you the model and your version. So there I have the old version still on the bottom. And that disappears once you do your first test or touch anything on the gauge for the most part. But you can also just go to the settings and toggle through the different pages on the settings. And on the last page, the third page, you come across the same information, which is what is my version. And you can see that on the top screen. If you tap that, it gives you more information about your calibration and other settings that are in the gauge itself. So if you do need to update it or check and see if it's updated, because you really don't know, you can go online and see if you have it. You can use a newsletter to confirm if you have the right version. But what you're really going to do is be going to the configurator, and you're going to plug in. What I do is open the configurator. My gauge is off. I connect the USB. Gauge automatically comes on, and it's almost always found, and it'll tell you if it needs to be updated, and you basically follow the prompts. So the configurator is under support, under software. You can download it directly, and if you don't have that, you definitely want to make sure it's part of your system on your PC. And again, you want to check it with the USB. It doesn't work with Ethernet. It's really a USB connection that you're looking for. So what to do is to do update. It downloads. It goes through scenario stuff. You want to make sure your gauge is charged. So it's like on red and maybe seeming to die. Your computer may not keep it charged enough. So you want to make sure that your gauge is charged well. You don't want it to die during this process. And your computers do not charge your gauge as much as it needs to be in order to get a full charge. So a lot of computer devices only may have 1.2 volts or partial volts, whatever it is that they use to charge your gauges. You may find that out with your phone that it doesn't actually provide enough to do that. So the other things that the configurator does is it also helps you establish network settings. So if you are going to use a network with a Wi-Fi gauge, then you can actually use the configurator to manage those settings and set that up. So let's say I'm going to use a router that actually has a security code. Then I need to actually go through and open up the configurator and go through the status of setting up all of those features. You may also want to do something like recalibrate the screen, repair images. These are actually more of a tech support. Some people don't buy the gauge with Wi-Fi, but decide to change it later. And there's actually unlocked features for the gauge itself. So if you later in time want to go from non-Wi-Fi to Wi-Fi, you can actually just buy a code and upgrade that. All right, I see if there's any quick questions. Anything I need to address, Jay?
There was a question about certification in Las Vegas in October. It said that we made available a form that he filled out for ACH. volume of house, etc. Is that form available on our site?
I don't know. We'll have to follow up on that. Noah asked, do we need the current firmware version for this webinar? No, but you definitely want to focus on the webinar. No, you don't want to like tune out. So as soon as the webinar's over, you can actually update your gauge and do that. So anything else? Okay, so I can put it to rest. There is no Mac version. Mac is just, it's not going to happen. So what is going to happen probably in the future is that more things will become mobile situations. So I mean Mac in terms of PC, a lot of things are headed towards tablet or phone, and that's really where a lot of companies are headed. I can't make any prediction, but there will be a time when you don't need a PC in order to update your gauge, but there's nothing in the sites immediately about that. So there are ways you can get around that with the Mac, but you do need some kind of third-party software.
Yeah, and Joe, just in case anybody out there is not clear about it, the reason why we're focusing on updating your firmware is because it makes a big difference. Sometimes there are small updates. At this point, the most recent update is a very big update. So there's going to be a lot of changes, and that could cause you some difficulties in the field if you were trying to run it with updated software or otherwise. So make sure that your version, your software, that your firmware is up to date.
Great, good point, Jay. So some people use the gauge, and I can tell you that for the most part, you're not going to like ruin the gauge or go anywhere. So I usually when I teach a class, I hand out a bunch of them and tell people to just go ahead and play with it. There is no reset button. There is no way to like, oh, let's go back to a starting point. But my goal is to make sure you're very familiar and more comfortable with it. So if you get someplace and you're like, I have no idea how I got here, it's my goal to make sure you understand what are some of the navigation tools and what they do for you. So if you go to settings, or if you go to, if you press on channel B and you go to the different results, these are the navigation tools that are on there. So the arrow always takes you to the previous page or takes you back home. All right. The three dots on the bottom right corner, those actually are toggling through page after page after page based upon where you're at. So most of the times if you're on a page like this and I hit the arrow, it's going to take me back to the home in the very beginning. You can also press the home button on the bottom to get you back to home. If you press it too long, it'll turn the gauge off, but if you just press it quickly, it'll take you back to the home screen. One thing I do want to talk about, which is about set pressure versus set speed. Right? So set pressure is what many people use in order to do their tests. Right? So they do set pressure, they want to do a blower door, and they do set pressure 50, or duct test, and they do set pressure 25. And the gauge knows. It can actually compare the pressures on both ports. And in the fan itself, it says, oh, you're depressurizing, or you're pressurizing. It can actually determine those. So there's never a negative button to press. But when I hit set pressure, I can enter it. But set speed is more like trying to use the speed control knob that's on the fan itself. So if for some reason your umbilical doesn't work, you get to a job site, and the speed control connection is not communicating with the gauge to the fan, I'm sure that's happened to somebody or may happen sometime in your life, then what you can actually do is use the speed control knob that's on the fan itself, and the gauge will still read your results, but you're going to control the fan with the knob on the side. And you want to make sure the umbilical is separated on one end or the other, which means that the gauge or the fan is separated. Because there is actually a connection. You can see the status light on the right side, green, saying that, oh, there is actually a connection between the umbilical and the fan, and that actually determines that. So unplug one, and you can use the knob. Sometimes that can be very helpful if you're doing leakage outside or some other test methods. So, but set speed is more of the process where I'm actually able to dial in the gauge that I want. So when I do set speed, see my get the next slides to come up. So let's say I enter set speed 44%. So he's just going to take the fan up to 44%, and then at the bottom you can see that I have these jog up and jog down into 1%. One of the reasons why set speed is a great feature is for people that do air sealing with blower doors. So what I can do on my first test is I can do set pressure 50, and then notice in the corner when I get to 50 pascals, what is my speed? So if I say, oh, my speed's 44%, I can stop the fan and then come back again and do set speed 44, and then jog up and down until I get to my pressure of 50 pascals. So what that allows me to do is that if people are going to open and close doors, go throughout the garage, open an attic hatch, that the fan's not trying to create or adjust to the pressure difference from these doors being open. So the fan doesn't rev up to try and make to increase the pressure to stay at 50. Then when somebody closes the door, it has all this huge pressure and wants to watch the door fall out of the frame. So this is just like using the speed control knob, but you're able to actually tweak it or tune it in, and then it'll stay at that percentage while you walk away and do some of the work that you're trying to do from diagnostics or air sealing itself. Hopefully that was helpful. All right, so there's my speed, and that's my jog up and jog down. All right. So there's a variety of stuff that you can actually do for code compliance, and most of this may be the U.S. standards, but there is a laundry list of stuff that's in here for European folks also. So most people test, and they do CFM. In fact, if you're doing code testing, you need to fill out a form that says CFM, and then you may have to fill out your ACH 50 or CFM per 100 square feet or CFM per square feet or a variety of methods that are in there. So if you just tap on channel B, it'll give you your list. And I got a couple of the slides that kind of go through that. So, or I go through settings and also do that. So let's go through one of the scenarios. So if I have a duct test and I have two systems, so here's the information by itself that these need to be tested and passed as individual units, not together. So if I have 2,400 square foot home and I'm testing one or the other, that's one of the things I would do. So I'm going to do that. So we'll assume that we have a system where I had one unit and I got 107 CFM from channel B, where my CFM is, for a 2,400 square foot home, and I need to be able to explain to the code official or confirm my code results that I have CFM per 100 square feet as my results. So my duct leakage, here's the math and how it works. I get my CFM directly from the gauge. The math looks kind of awkward because you always have the bigger number on the outside, and as I move through, I can actually you get your 2,400 divided by 107 divided by 2,400 equals 0.044. We multiply that by 100 to give us our percentage, or per 100 square feet. And what I end up with is 4.458, and you can reduce that and realize that I can actually also get that directly from the gauge. So instead of trying to do the math or pull up my phone to figure out how I'm doing, I can actually get my results in CFM or CFM per 100 square feet. One of the things that people get lost on, we talked about some things we wanted to make sure that people are understand some of the errors that can happen. So when I tap channel B, usually you probably are in CFM if you're doing the American standard. And so if I want to get to CFM per 100 square feet, I just tap it once, and whatever is highlighted in red, the brighter red, is where it actually will stay, and I can actually press the arrow back or the home button. Right? But what sometimes people get in trouble with is that they may tap it again thinking that that's what saves it. So these are all of the different units that you can actually get your results in. So whether it's actually meter cubed divided by hours times meter squared. So again, CFM per square foot, sometimes people use that in commercial duct testing, or it's also used sometimes in Washington State or other California factors. So again, anything you're looking for, you may actually have as a metric or a unit. It's on there. So if you wonder why you've got something that looks strange, I don't see my CFM, you need to continue to tap it. And notice that there's CFM per 1,000 square feet and per 100 square feet. So most of the ICC code compliance is CFM per 100 square feet. And then I have that highlighted, press the home button, and I go back. I notice that there's some challenges with some of the text when I go from PC to Mac. So one of the things you want to make sure you're doing is, if I'm going to do CFM per 100 square feet, or CFM per any, or those other requirements, or the metric type units, you're actually doing a calculation that's based upon an area. So you must make sure you enter the area. So notice that after I changed my results in the left-hand corner there, I now have an area that's telling me you're going to be basing it on this. So, or I can change it. You can also do this live. So if I'm doing a test, it actually says, wow, you are seeking 25 pascals for an area of 1,000 square feet. So if I decide, like, oh, this house is actually a different number, I can tap on the area or tap on the settings, and they take me to a scenario where I actually would do change the area, enter my new square footage. Again, this is like a surface area, not a volume. And then I can see in the back that I've actually changed it. So it was easier to make slides where I came back to the same number, but I could have changed my area and it would be showing it here either during a live test or on my home screen. So if you're doing calculations, you want to make sure you have the area correct. This is the same as if you're doing a blower door test. So I need to know the volume of the house. So when I calculate the volume, it's ACH times the equals CFM times 60 divided by the volume. So again, I get my CFM 50 from the gauge itself. Sometimes you'll write that down on your sheet. I know what my volume is. It was 33,000 cubic feet. And so 1,900 times 60, and all of this math is done automatically in the gauge itself. So again, some people use an Excel spreadsheet or their phone, but here's one of the easiest things you can do. It's just actually tap on channel B, change it to ACH, and you actually get your results. Again, this also comes with something you must do, and that is you must change the volume that goes with that. So CFM, ACH, there are no other units for ACH. You basically just pick ACH, and you go back home, and your volume is something you want to make sure you change. So again, you can see that it shows up on the left side of the gauge or on the bottom. Settings, same concept, but instead of area, notice you have area on the right side above volume. So there's a volume and an area that you can then change. Set your volume, and now you can see that you're confirming that my air changes per hour is based upon the volume. You can do volume in metric or imperial units. I got one other feature I'll do. We'll check and see if there's any questions. All right. Okay, so one of the things that people sometimes don't really use or understand the full feature on why it's so valuable is the or the extrapolation feature that all gauges have, whether it's the Energy Conservatory gauge or if it's the DM2, the older version, or the DM32 Smart gauge. That let's say you're doing this very frequently happens on a blower door test where the numbers are kind of moving around or jogging or vibrating. You're like, wow, I can't stay on 50. It keeps going to 45, 47, 52. Even if I change my time average, it's still kind of fluctuating. But I need to write down the results that are at 50 Pascal. That's what's really required. Or same as a duct test. It's a little more stable though. So you can see in the upper left corner is this at feature, and it only shows up while you're doing a test. So here I'm actually doing a blower door test. You can see I'm seeking 50 pascals in the bottom left, and but I've only reached 45 pascals. But when I turn on the add feature, notice that the CFM has changed from 2798 to 2996. So, and that's also again based upon that the gauge is going to extrapolate what would my results be if I was at 50. So it's a great feature. I just use it all the time. So I hit set pressure, 50, and as soon as it comes up, I just turn on the add feature all the time. There really is no reason to not just use it, just to make sure you always are getting your readings at whatever test pressure you're trying to achieve. The at feature is based upon whatever test pressure you're actually trying to seek. So if I'm doing a duct test, it says, oh, set pressure 25. The at feature will then be at 25. One of the ones that can also be used slightly different is if you use set speed, there is a setting that actually you can actually do a default add pressure. So if you're playing with your gauge and you're going through the settings, you can see on the second page it says default add pressure, and that's designed so if I'm using set speed, I can still use an at pressure reading. There we go. So one of the things that it does, it keeps the previous settings, which I think is always very helpful and handy. Smart setup, so that, let's say if I used a blower door last time on range B, and I had it on CFM, turn on the gauge, that's how it comes up. If I was using a duct tester or any other results, CFM per 100 square feet, boom, there's nothing to go through and reestablish or set up completely whenever I turn the gauge on. All right, keep moving. So when I turn the gauge on, this is what I usually do when I teach a class, is you understand what they are or how you're going to use it. So I turn on and make sure that I have these settings. So that I confirm that I have Pascals. Confirm that I have CFM. I usually start at CFM personally, and then I'll change it to my results because I usually need both. So I confirm that the device, it's the same device that I have that I'm testing with, and I make sure I look at the range and confirm that that's on there. So the range could be a ring or a plug depending on the device it is. So once I confirm I have these settings, then I'm able to begin my testing. And it really is as simple as doing, set pressure, follow the quick guide. The quick guide is very basic, but these are the routine that's there. Enter 25, I'm up and running. And then I can also just turn on the add feature to get my results at 25. So it's just a matter of tapping a few simple buttons and you're off and running. Okay, so I got a few of the things that are on baseline and some other stuff that are common questions that actually occur, like how do you do baseline, or how do I know where my baseline is? So the baseline is used for a blower door, obviously. There are rare times you may need to use it for a duct tester if you have a very old leaky house, leaky duct system. So the reality is if I'm setting up my gauge and I have a huge fluctuation on channel A, before I do my test, then I have an issue. Usually maybe it's a connection, there's some kind of wind, there's some kind of air moving in and out on channel A. So that's very common to have when you do a blower door, that I have pressure differences from inside the house to outside the house. Some options you can do if you have a high number fluctuating already is you can actually move that reference tube. The red reference tube can be moved anywhere outside. Jay's got a method that he uses where he puts it in another container. Some people bury it, some people put it in a tennis ball. As long as it has the ability to get atmospheric pressure and is not actually something that's closed off like a bottle that can actually create a wind across it that actually creates pressures. You can take it all the way around to the wayward side where the wind is not blowing and extend that as whatever you need to make sure your baseline is a stable reading. But you don't need to just have it right outside the door, and you never want it in front of the fan. Okay, so here we go, baseline. So baseline, when I start, I hit settings, and the first thing at the top is the baseline. It says there's none taken. So I tap on the baseline, and I can either capture or clear, so I don't have one, so I'll capture the baseline. And it's running until I decide to end it. And it's telling you below how long I did it for. We highly recommend you do something for at least 10 seconds. If it's a windy day, 30 seconds minimum. If you really feel that this number is closer to 2, 3, 4, 5, then a minute would be definitely much more appropriate, if not longer, or realize you probably should move your tubing to accommodate the situation. So once I accept it, I hit end capture, then I can either clear it or keep it. So if I captured it, if I can also think, oh, I didn't like that, I'll clear it out. I end captured, and it's telling you what my baseline is. So I have a positive 2.8 Pascal. I hit the home button, it takes me to the home, and you can see that under channel A, I have pressure with a 2.8 baseline. So in fact, your gauge is probably reading 2.8 at that point. So one of the things that is people forget about is that they may go from here to go do a duct test, and if you do not clear the baseline or turn the gauge off, then you still have a baseline. Or some people will just reset it. They're like, oh, something's not right. They'll turn the gauge off and turn it back on. You must reestablish your baseline. So the baseline is there until you either turn off the gauge or eliminate it under the baseline settings. So the DM32 also controls Energy Conservatory fans. So really what you're going to do is you get a speed control adapter. You can see that little piece below the scenario. In fact, I'm just going to go back and do that again. So you have the DG700, and basically that no longer is used. In fact, most people just trade it in to buy the DM32. So the DM32 comes with a speed control adapter. It's a little black box that sits on the bottom. And basically what you can see is that it connects from the DM32 into the little black box into the speed control that's on the Energy Conservatory device. Oops, I guess we have two of them. All right, so the speed control adapter is over there on the left, and you can see the devices that it controls on the right. This is one of the screens from the DM32. So it controls the Minneapolis duct blaster, the blower doors, different versions, but you do not need the speed control adapter to do the exhaust fan flow meter or the true flow grid. Those are just actually devices that just receive pressure. They're not actually controlled by a gauge. But those are also things that already have built-in control in the gauge itself. So if you want to use the exhaust fan flow meter or true flow grid, again, you do not need a speed control adapter to do that. And again, here's the offer that's been out there for quite a while. You can trade in your DM2, a few people have that, or your DG700 for a little bit of funds. It's actually a phenomenal deal, amazing discount to upgrade to the DM32 Smart Gauge. This is a non-Wi-Fi unit. It's just the basic gauge. All the things we talked about today, you can do with a non-Wi-Fi unit. So if you want to add Wi-Fi, you can do it later or do it when you buy it. It's better to do when you buy it because it's already done at the factory and it's a lot easier to just not have to deal with the hassle. Okay, any other? So for those of you that may be updating your gauges or doing things like that and you have a problem, support at Retrotec.com. Again, support at Retrotec.com. Lee is the guy who will be responding to your emails or your phone calls, and he's on top of this, so he can help you quickly with what kind of issues you're having. One of the things you want to make sure is that the gauge does not get separated or dies while you're trying to do the firmware update. So confirming for Paul that the Wi-Fi is a separate upgrade. You can do it when you buy your gauge or buy your equipment, like you can buy a duct tester or a blower door and get the Wi-Fi included, or you can update it at a later time. I made a couple of the slides to try and explain for folks what the difference is between the DG700 or the Retrotec DM32. There's a couple that are actually very fundamental on how they actually connect channel B. You may find a variety of devices that are out there. Some people will use the exhaust fan flow meter and they don't set it up. They follow the instructions for the DG700 and apply that to the Retrotec, and it doesn't actually work. And I'll explain why. Is that channel A works exactly the same on both gauges. But for the Retrotec system, they use the reference to connect to their fans. Remember, yellow goes to the yellow fan, right? So if you follow the same setup as you would on the DG700, then you'll find that it's not going to work correctly on the DM32. So I got some illustrations to kind of show that. So if my input is on the DG700, I would probably be using the reference on the DM32. So when I was first learning this and became an instructor, there's a lot of information out there about the DG700 with these kinds of illustrations, but this is the reality, is that if you're going to apply these on channel B, you're probably going to be switching over from the input to the reference to get the proper readings for a variety of devices. So for the Energy Conservatory exhaust fan flow meter, this is the actual connection that you'll be doing. You do not use the input as you would on the DG700. So, and you can see that I actually have settings that are on the gauge itself that show the exhaust fan flow meter and show the actual, what I would call is the range or the opening size, E1, E2, E3, and then I can actually get my results on channel B just like you would on the DG700. One of the things I usually recommend is actually to tap in on both channel A and channel B, because there is actually a pressure requirement that you shouldn't exceed. You shouldn't really go below 1 or above 8. So you don't really know that if you're getting a false reading. So if you actually create a T and reference use the reference port on channel B, the yellow, and actually also still use the blue input on channel A, I can actually see what my pressure reading is and also get the result on channel B at the same time. Okay, so any other questions on that? I'm trying to read Paul. You have a couple last questions there. I wasn't sure exactly what you were reading. Yeah, I think he's pointing out a point is that the DG700 does not actually control the fans unless you use cruise. You can also use cruise on the DG700, which is similar to set pressure as a concept with DM32. But in general, most people are using the speed control, which is just a knob that you're dialing up or dialing down. So the gauge is just reading those results. One of the features that's in the DM32, and it is a phenomenal, super cool feature that allows you to do a variety of options and testing, and you can actually download this in the duct leakage manual that's in there. And what it allows you to do is create your own exhaust fan flow meter just out of a cardboard box. So basically, the way that all things are working, whether it's your fan or a variety of other options, is that you have a known opening size and I have a known pressure difference. And if I know both of those, then I can actually confirm or calculate the CFM that would go through it. So on the gauge, it actually has if I go to devices, on the very last page, it's got this thing called hole flow. And I can actually enter a square footage or square inches or other different units. So what I made is my own cardboard box. The opening should have been a little larger, more like 4x6 is a great opening that actually allows you to do a lot. You can tape it back down if you needed to. So again, you can follow the instructions on how to do this, and you can actually just have your own box. You want to make sure that your pressure tap, which you can see in the picture, is off in the bottom corner. Using a static pressure probe is definitely recommended, but you can just put the tube in and make sure it's not in the middle of the flow. It should not be part of the static or the pressure that moves through the box. It should just be a static pressure off in the corner. Here's where this can actually be a major resource, is that I've got this bizarre kitchen exhaust fan that may be over an island, and now I can actually take a cardboard box and seal it to the unit and actually use the hole flow. So my hole flow number would be the size of the bottom of the box here. So whatever this was, whether it was 8 by 10 or whatever it was, that's the number I would be entering in the hole flow down here, and I can actually confirm how many CFM this was moving. So if this was a kitchen exhaust fan, it would be failing because I only have 85 CFM. This does not have a max or minimum limit like the exhaust fan flow meter does, so you can go above or below the 8 Pascal kind of limit. So it's going to just actually calculate what my actual CFM flow is through the device that I made. Some people actually make these and they actually get a plastic container and mimic the same kind of concept. So someone asked, is that a separate cost for the speed control adapter? It is. I don't really keep track of costs or those kind of things, but you can contact sales at retrotec.com, and it does include an entire tubing kit, which is worth like $35, of all the different colors, and gives you a variety of guides to make sure you understand how to do that. Someone says they use Corey Breed's vent caps, and the pressure connection is on there during the blower door test is placed in various registers to kind of use that as a whole flow test. So there's a lot of, when you really understand the pressures of the gauge and reference versus input, there's a whole lot of things you actually can do and really fully understand. I think this really only takes one slide because I want to just show you a few other things on the gauge. So if you're going to do a pressure pan, again, it's diagnostics only, you don't get CFM from that, then this is the pressure pan on the upper left corner, and I just connect that to the input. I don't read any part of the bottom of the gauge itself. So it doesn't matter what device I have, it doesn't matter what's reading on channel B, so I only want to read what's on channel A, and that allows me to do the diagnostics from a variety of stuff, from where's the air barrier to are the ducts leaking, to what kind of leakage do I have on the envelope. All those are great ways to use a pressure pan test. And you would actually do the same concept for zonal pressure. A lot of things that you may use for diagnostics just uses channel A on the input side to get your reading, and the rest of it does not matter. Sometimes you may get a reading on channel B, but it's only from some accident or because you're moving things around. All right, I want to move to another level here and see what we have as some options. Okay, so I made a couple of slides here that kind of review what we're after and go through them on actually the. So what you're seeing here is a PowerPoint on the left, and on the right is actually Virtual Gauge, which is an app, but it's the easiest way for me to show you what's on the gauge that I have sitting right next to my computer. We used to do videos, and it just was very slow and cumbersome and hard to focus and became a nightmare. All right, so what I'm going to do is I can tap here on channel B, and notice earlier we talked about all the different settings that you have. So I'm going to go to CFM, and then notice that's the bright red one, and go back to the home button. And now my goal is to try and get this to match what we have on the left side. Okay. So there's some other things that are on here, so let's go through a few real quick. So I'm going to tap here. All right, here we go. All right, so channel A, and this is also where the hold feature is. So if I go over here and I actually tap channel A, which some people think they can change my test pressure from water column to Pascal to pounds per square foot, that actually is done through channel B. So if I tap here, it actually is activated hold. So if I have a reading that I want to get and I want to hit hold, that's the easiest way to do that. Tap again to release the hold. On channel B, then I got my CFM. We talked about some of the results that are on there. So I want to do some other ones that I didn't really have a chance to do as a slide, but I can do much easier live. So I can actually change my results by tapping on channel B or in the settings. They both give me this option. So if I usually just tap here, and you saw that we did air changes per hour, we did CFM and CFM per 100 square feet. But this is also where I change my results from channel A to Pascals or channel B. So if I selected Pascals and I go back home, notice that I have Pascals on channel A and channel B. And this is how I would do my field check. So we talked about connecting the yellow port from channel A to channel B, input and reference. This is how I'd actually set up the gauge to do that. Again, I tapped on channel B and I selected Pascals. So I'm going to leave this at Pascals and I can actually do CFM, and that's how I can get back to where my original settings is to do most of my tests. So again, I got Pascals and I have CFM. So let's go through some other options. We did the CFM per 100 square feet, per 1,000 square feet, and the other metrics. At the bottom here, I have EQLA at 10 pascals and in square inches. And I can also do the similar things here where I can actually toggle that for CFM's square feet, square inches, or centimeters squared. Sorry. What it is sometimes people want to do EQLA, which is trying to explain to somebody maybe how big the opening is in their house or in their ductwork. The easiest one to use is actually on the next page. Remember the three dots take me to the next page. Here's a whole other set of different results that I can use. So here's EQLA per square foot, or square inches, or various other metrics. So if I'm doing a blower door test, I can say, oh, you've got 3 square feet of an opening in your house. That's almost a window, open all the time. So if I did that and I came back home, here's my results in EQLA and square feet. So I can do my test. So this is a duct test. I could be telling people how big of a hole they may have in their duct system. And if you can't get a result, then I may have to go to square inches to convert that. So again, I go back home. If I don't have a result, it may also be because my size of my range or ring was not set correctly. Okay, so these are some of the different settings that are on here, and again, I toggle from the beginning page that I had to the second page. Some of these are Canadian usage in terms of their results that they're always looking for. Effective leakage for square inches or equivalent leakage. I'm going to run out of time if I try and go into some of those other details. Okay, so I'm going to go back home. Let's go to a concept of what's under settings. So we talked about the baseline. We talked about the area and that it's used for calculations for CFM per 100 square feet. We talked about the volume and that's used for air changes per hour. And the time average. So notice on my left screen on the PowerPoint, at the top, it's actually got 5 seconds as their time average. So I can select here and do 1 second, 5 seconds, 10, or I can do a manual where I can actually say, oh, I want to do a 60-second time average. And now when I do it, notice that if you're going to do a time average, you must wait at least 2 time factors of what that is. So when I first come back to the gauge, I will not get any reading for my first 60 seconds. And then the next 60 seconds may actually be including some of those other readings. So sometimes you really want to wait 2 minutes before I would get my first set of readings. So let's put this back to 5 seconds, and it matches my image on the left. And then notice here I also have the results to be displayed. It's the same page that I got if I just pressed Channel B. All right, under settings, there's also another page on settings. These are some of the things that are on here from network. So if you do not have a Wi-Fi, you either have disabled, Ethernet, oh, great. Oh, great, I lost my gauge. Love it. This only happens when you're trying to do a webinar. Bummer. So 1 second. Okay, to do my virtual gauge, I'm going to connect it with Find Gauges. Connect. Great. Okay, I'm back home. Make it a little bigger. Sorry for the, it always has to have some kind of glitch, otherwise it's not a successful webinar. All right, here's my other little screen that I had next to it. So I'll go back to settings again, hopefully it won't die. So on the second page here, you have your default add pressure. If you I mentioned that earlier, that's how you would use for set speed. And you can tell when to power down after an hour or less. I usually turn the sound off. You can recalibrate the touchscreen. All these things are pretty self-evident when you actually start playing with the gauge. But some people wonder where they're at or how they actually get to them. Again, on the last page, I can change my language or confirm what version I have, or the calibration date and the serial number. All that information is all directly on the gauge here. So again, some other results that I had set up here for you were at the top is where your speed is displayed and the time average. One of the things that is, for example, until you get used to it, is the only place that you can change your range or the device is actually touching this image. Under settings, I cannot actually change the device or the ranges. So a lot of people use settings thinking that that's where you go to change everything. And you can do everything except change my range or change the device. All of that is in this one section where I actually have to touch the image itself. The first time you touch it, I'm going to go back home. So the first time you touch whatever device is on there, it asks you to confirm your range. So you must select a range. And once I select a range, then it's actually going to go back and begin to allow me to test. If for some reason I'm going to go to do a blower door test or a different type of test, at the bottom I obviously hit Change Device. And notice at the top here, these are the Retrotec duct testers. And what you can see by the icon is the 240 and the 340. Both of these have the larger flex duct. There's a 350, mostly used in Europe, and it has a smaller flex on it. There's a 450. And notice that the output is slightly different for each of these devices, or the face is slightly different, so you kind of can confirm your number with may also what is the device you're using. I'm going to go to the next page. So these are all the Energy Conservatory devices. So if I wanted to do a the blower door and I have the Minneapolis device, I can select it, select what ring I'm using, and if I do not have the speed control adapter, I can still read the results. I just cannot control the fan. I need the extra speed control adapter to control that. I'm going to change my results here because we're now getting familiar with the gauge. And let's just use CFM, and I can go back home. So now I can actually do, yes, Jay, go ahead.
Oh, you can still control it from the power or from the speed control knob on their controller, though, right? So you just
That's
can't
correct,
control it from the gauge.
What I can't do is automatic pressure or speed. So what I can do is, unless I actually have the speed control adapter, then I actually have to use their speed control knob, and then I would get readings on the channel A and channel B based on that device. If I have the speed control adapter, then I would actually connect everything and be able to hit set pressure and run that thing. Let's go through a couple others real quick. So if I change the device, again, these are exhaust fan flow meter. You can see I have the exact same types of openings that it has. We'll go back and change another. True flow grid, there's two different sizes. And on the last page, this is that whole flow where I talked about that I could just select this as a device. It says how big is the hole on the bottom of your device. So I could say, let's say it's 15 square inches, and I hit set. And now there's nothing to control, but it'll actually be measuring the flow that moves through that. And again, you can use a T to do both pressures, or I can just read on the yellow port of the reference and get my result in CFM. One thing I do want to note for those of you that may have just recently checked your firmware, this is a major catch for a lot of people. So again, I know you've been hanging around, but here's a really great thing as to why you hung around. Notice that this says Retrotec blower doors, but I have a 300 on here. This is actually a duct tester. So normally people use this for a duct tester, but it doesn't say 340, it says 300, and there's no flex duct attached to it. So Retrotec allows you, and it's calculated to use your blower door for smaller structures. Maybe it's a passive house, maybe it's a very small unit, or maybe it's 800 or 1,000 square foot house, or maybe a condo that's very tight, and you don't need a blower door. You can actually do it with a duct tester. And they have different flow curves based upon using this duct tester in either in the window, which they have a window frame, or you can use it in your main doorway frame with a special cloth that accommodates the duct tester. So again, you want to be careful that you don't pick this as you decide to do, oh, I'm going to go do a duct test, because there's no flex duct here. So this is not designed to do a duct test. It's designed to do a blower door test. So notice it says 300 versus 340. The rest of them are all pretty straightforward in terms of the numbers and the calculations that you're going to get. So the new fan that's out there is the 5000, and it has a series of different ranges. That's why you see the different cut in the front, and trying to distinguish the difference. So I thought that was very informative. So I'll go back to matching the same device I have on the left. So it's a 340, and check the range. So notice the range numbers are below. And one other change that did happen recently, for those of you that updated, is that, in fact, they have a new icon that comes out for this. So for the 340, they actually have this cover, and it actually, when you take out all the plugs, it actually is called range 102. If I first put in the first plug of 74, then that actually is the, or I picked 47, 74, there it is, okay. All right. Pick open, okay, great. All right, so hopefully that's a decent overview where people feel more comfortable with their gauge. Any other questions that you have? I got a few other things I'll kind of go through for those that hang around. We appreciate your time. Any other questions or something you wanted me to touch base on, or something that didn't make sense, please throw your questions out. So I'm going to do a quick test here. So I can do set speed or set pressure. I'm going to follow what most people have, and that is set speed and 25. You may hear the fan I got in underneath my desk. It's going to kick on. So I can now tap different pascals in terms of I can go jog up or down 5 pascals or up 5 pascals. So some people want to do a more of a multi-point reading. So you actually can do that fairly quickly on here and write your numbers down. You can press hold if you needed to get them as you reach those test pressures. So one of the things I can do while I'm here is while it's actually running, again, I can turn on the app feature so I get make sure my readings are at 25. I can also change my readings live. I don't need to like turn it off or stop. I can actually go to CFM per 100 square feet, go back home, and know that I have to change my area. So let's say it's only a 1,200 square foot house. So I changed the area, and I did that under settings. So now I'm actually getting my test results of call it 16 CFM per 100 square feet at 25 pascals.
So hey Joe, I just want to remind everybody that Joe is using a virtual gauge which is connected to an actual DM32 in the room, which is connected to an actual fan. So those are what you're seeing on your screen are actual readings. That's not a simulation.
So what we should try and do is actually have a gauge next to the desk with a video on top of it, and it just was a nightmare. It just was very problematic. So so again, here I can jog up, and you can see at the bottom here is now seeking value of 30 pascals, where I can jog down. And again, it's also telling you my area that I'm extrapolating to with my results. And I can press stop. So hopefully, maybe there's always something that you maybe catch out of the webinar that you're like, oh, that could be handy, or I'm glad I caught that. So hopefully we had some of those moments today for you. So someone asked if they have a whole flow test. You can simply turn on the mechanical fan, which you're testing. And so the question is, I'm going to do a whole flow test. I simply turn on the mechanical fan, which you're testing, the exhaust fan or kitchen exhaust fan, bathroom exhaust fan, and neither the blower door or the duct tester is engaged. That's correct. So you're not trying to create any false pressures in the house, because you really just want to measure this exhaust fan by itself. So that's actually the purpose, is to find out what kind of flows it's happening all by itself. So you basically just put your cardboard box or your device, exhaust fan flow meter, over it and connect it to the gauge, and you get your results. You can change the size, so I'll do that again. So if I just hit set speed 25, and you can set any speed or any I'll do set pressure. Sorry, you can set any pressure I want. So if I for some reason need to test at a different pressure or do something different, so I do set pressure. I turn on my app feature. So let's say that I'm going to go back to CFM, which is a common way that most people start, and then you decide like, oh, I need to do this in CFM per 100 square feet. And at the bottom it tells me my area is 1,200 square feet, and I can change that by just going to settings while it's running and change the area to, we'll make it 2,500. So I just changed the area that it's calculating to 2,500 square feet, and you can see my results were cut in half basically. And you can do the same that for blower door, air changes per hour. So one of the things that is an issue for people is that again, remember that it keeps your settings, so it always keeps your area and your volume in there. So that's why you want to pay attention at the bottom, reminding you what it is. So if I hit stop, it shows up a lot clearer. It says, oh, here's the area that you're testing to. So if I'm on this, or if I'm going to use these kind of settings, some people do it when they're still on their home screen, so they're reminded to change that. So if I change the device to blower door, so I'll say I have a 1000, and we'll say it's on range B, and I'm going to use air changes per hour. Oops. Then I go back home. Sorry, made my mistake. So here I have a volume that I can change and be like, oh no, it's actually more like 18,050 cubic feet. So now I can see what my volume is for my blower door test. And I can easily hit set pressure, 5.0. If it gets loud, I'll lower the pressure down. So right now I have live air changes per hour based upon this cubic feet, and I'll turn on the add feature to make sure I'm getting my readings at 50. So I use a duct tester to simulate the blower door, so it's not like it overshoots the pressure. So you see it came back pretty quick, but I'm trying to get my readings at 50, because right now I'm at 43, 44, it'll climb back up. But as this thing fluctuates around, which is very realistic in a real test, I'm able to confirm air changes per hour at 50, at 50 pascals. So there you go. Now I can hold this. I can say, okay, hold, and I can write this number down. Here's one of the cool features for those of you that are stayed late. So I can actually right now, I'm doing a blower door test. I got 50 pascals. I got my air changes per hour, and I hit stop. Notice, if you can hear it, that the fan just stopped, but I still have my readings on hold. And I can actually go down here and change my readings back to CFM if I need to write those down, and go back home. So I can continue to alter the readings that I have in the gauge until I release the hold feature. So again, I can say, oh, what was my air changes per hour? And it calculates those. So but once I release the hold feature, then everything will get, all the pressures will get wiped out, including the readings. So that's a nice little feature for those of you that want to get your test up and get rid of the noise of the background, hit hold, and get your readings and write them down.
So yeah, Joe, a question that comes up sometimes to me is, why would you ever want to set speed? Why wouldn't you always set pressure? And the answer to that is sometimes when you're actually working in a house, or let's say you're just looking for leaks, and the results actually aren't important. So let's say you've run your blower door test and you're just looking for a CFM at 50 number, and you used set pressure, and you set it to 50, and it gave you your pressure. But now you want to walk around the house and you want to look for leaks while the fan is running. Maybe you're using an infrared camera. In this case, it's actually probably better for you to set speed, because what will happen is if you set pressure and you open a door, your fan will work even harder to bring it back up to that pressure. So you can get all kinds of issues with, with the sound, or with the amount of noise, or if you slam the door shut. We've all heard the story of somebody else. It never happens to us, but where you shut the door and the fan actually pulls itself out of the doorway. So if you set it at, say, 25% speed, it's just going to constantly run at 25% speed regardless of what the pressure, or if anything opens or closes in that house. And that's going to make it easier for you to move through the house, open up doors, and open up windows, or walk around the house and look for things.
So let me show you how that might look. So if I'm going to do, here's how I kind of can figure out what my set speed might be. So I do set pressure 5.0, and again, it'll probably overshoot it as it normally does, but it'll stabilize here fairly quickly. So notice my set speed up here is what I'm trying to pay attention to. That once I've gotten to 50, and again, when you set pressure, it's going to go to 50 and wants to stay there. So if it overshoots it, it says, I'll slow down, I'll get to it, or maybe whatever kind of speeding up I need to do, I'll get there. But the goal is that it wants to get to 50. So it overshot, it undershot, it's coming back up, it's nice and slow. So my goal is to get around 22%, somewhere in that range, 21%. Okay, and I can tweak it back in. So we're going to say stop. And now when I do set speed, what's going to happen is that it's going to just take the fan motor and get it to that speed, and I can also get similar results. So wait for that to zero out. So if I hit set speed here, set speed, all right, and we'll just call it 20. So I'm going to do 20% of the motor's capacity. So 100% is super full-blown. The motor's going as fast as it can possibly go. You usually need around at least 3 to 5% to kind of get any kind of reading out of the fan anyway. So now while that's happening, if I overshoot or undershoot, I can tweak the fan instead of tweaking the speed control knob on there. And the reason that this can be also very helpful is that I can now walk through the house with, if this is a Wi-Fi unit, now I can use these remote devices, my phone or a tablet, to tweak it back down if I really needed to stay close to that. Okay, so I can increase slightly up. So notice I went from 20 to 21. And you got to give it a few minutes to really kind of find its balance. All right, maybe we'll go 22. So my add feature is off, and again we're using set pressure, but I can use the add feature. All right, I'm going to take this back to CFM, so we're on a common page here. So if I can do CFM, my add feature is based upon whatever my settings are here. Remember we kept talking about this default add pressure. So my default add pressure, I can change it to whatever number I want, but usually it's 25 or 50, but you can make it anything. So this default add pressure is what I'm using right now. So I'm doing a blower door. If I was doing a duct tester with the same method of set speed, then I would actually go back and change that to 25, so I could actually get my results at 50, even though my toggling up and down was only getting me around 49 or just under 50. I do want to shout out to Mark Lira and his group of folks in the room. So you're in great hands for those of you that are out there. And if you have any questions that we weren't able to answer today, or don't let Mark make anything up for you, you can send us an email at support@retrotec.com, and we'll gladly fill you in. But you're in great hands with Mark Lira. Many of the folks out there have been very participatory today. It really makes it fun for us in the background. So we just want to say thank you so much. All right, I'll hit stop here, and I did have a couple other slides that I'll just go through these real quick. So my point was that you can make sure you're using the bottom of the gauge to keep track of the information that's in the gauge, whatever. Sometimes you may do a accident, but you may do set pressure, and instead of hitting 25, you hit 28. And down here it tells you that. It just tells you that you're actually seeking 28 pascals versus 25. So when you're wondering why it keeps going to 28, then you understand that you told it to. So these are some of the great information that's in the gauge that most people kind of forget about. There's only one, even though we go longer for BPI credits, for those of you that are asking. Someone asked, is will hole flow create a large enough hole work on an air handler? I believe it would. It's really designed on how much pressure is going through there. I'd be very careful about where you set your probe. Great audience today. We really thank you. I will be back day after tomorrow on how to use Fantastic, which is automatic software for Retrotec, whether you're going to use 1 fan, 2 fans, 7 fans, or 25 fans. It's the same concept. So many of you that are doing 2015 testing, you'll need to pay attention to some of the different options that are out there for automatic testing. So someone asked about the advantage to set average at 5 seconds rather than 1 second. You would always want a quicker measurement for blower door testing. Retrotec, I didn't bring it in this slide today, I didn't think it would fit, but they do a running average, which means that as soon as your first setting is on there, whether it's 5 seconds, you get no reading, and after that, you get a constant reading. So it looks as though it's actually live, but it's giving you the last 5 seconds or 10 seconds as a running average. So I would encourage you to just use 10 seconds for all of your tests, all of the time, because that's one of your most stable readings you can get. If not, 5 seconds would do well. I would not use 1 second, especially for a blower door, because it causes too many things to kind of fluctuate around. You really want to get an average of something that's the most recent test pressures that are running through the fan and the gauge. All right, we appreciate all your questions and all your interaction. It was great. So there was one last question which I have to take. So it is there any advantage to using a positive rather than negative pressure for duct testing? Very little. The only time that there is an advantage is because you have to do it. Otherwise, it is always your best practice to do negative or depressurization tests for duct testing. It's a common question we get. All of your duct mask or duct seal gets pulled tightly. You actually know what your number should be. You're actually trying to get the smallest number you can to pass, and that's the best way to do it. So positive things can cause things to leak or move out. And so if you have to do positive, you should still start with a negative, just so you know that you have this number. Like, oh, my smallest number is this. And then if you do a positive test and it gets any larger, like significantly, you just actually opened up one of your registers from your duct mask. Joseph has the same question. Is it better to do pressurization or depressurization for blower door? The reality is it depends on the circumstances. If it's a newer house, everybody just depressurizes just because it's has less of an impact on the interior of the house. But if you have an older house that has some kind of conditions, you may want to consider that. But in general, it's just more common to do a depressurization test for blower door. I think it has a lot of just convenience on the tester and the homeowner in terms of not bringing in all kinds of stuff from out front or blowing a bunch of stuff throughout their house in general. So, all right, everybody, that's a wrap. Jay, you want to take us out of here? Thanks a lot.
Yeah, definitely. Again, thanks everybody who came. You know, we really take your time very seriously, and we're really glad. We hope that this was useful for you. It's always a great sign to see how many people have been on the webinar for over 30 minutes past our usual allotted time. So I want to give a big thanks to people in different time zones. Some of you in the UK and Asia who are up very late for this. It's we really thank you. I know many of you are thanking us, but I think we really thank you for